So very good afternoon to all. We were started discussing unit number 5, where we are only going to see about various case studies. Okay, this is little bit civil department oriented because the softwares they use and all we doesn't know, and we cannot fully understand that software and all. So there are some softwares they are using and they are trying to predicting and they are try to tell about the future. Okay, so it is similar to our MATLAB software, but they use it for hydrology and all. Okay, so last class I think we have started with a case study on landslide and drought. So today let us discuss on floods. Okay, so floods they divided into two types. One is called coastal flood. Coastal flood is due to sea, and one more flood which is due to overflow of river. Okay, so there is two difference. So when you say coastal flooding, that is because of we all know that like storms, when that used to cross, you will have a very severe effect, and that as a case study we will discuss today. And the one more thing, next flood is nothing but the flood due to overflow of river. Okay, so these two case study we will discuss today. So we have three more to discuss that we will discuss on upcoming classes. So coastal flooding, and this is coastal is flooded because of storm surge assessment we do. Okay, so let us start. What is coastal flooding? So coastal flooding occur normally dry or low lying land is flooded by sea water. Okay, so water which is going to enter and destroy is your sea water. Okay, so that we call it as coastal flooding. The extent of coastal flooding is a function of elevation of inland flood water penetrate, which is controlled by topography of the coastal land exposed to flooding, which means the land elevation, they call land elevation. Land elevation is from the sea level, what is the rise in the level of land in terms of angle or degree they call, and it is not same in entire coastal. I think you might have all went for Marina Beach, and similarly you might have went to Pondicherry also. Okay, both are sea coast, but there is a huge difference. When you see Marina, the land area is more from the level of sea water. Say that let us assume that you have a road which is Mount Road on your IG office, where that angle is very gradually increasing from the sea level. So this area will get lightly affected where compared to the coastal area of Pondicherry, where you cannot see even sand. So seashore is very close to the land, the soil is less. So that is what they say, the topography or the elevation, they say this is the topography or the elevation they say. So depending upon that they say the flooding will change. Okay, there are two types of flooding. One is called direct flooding or over drooping of barriers or breaching of barriers. Okay, so direct flooding is where sea height exceeds the elevation of the land. So when this sea level, if it exceeds the elevation of that particular place, then water will come inside, that's all. Okay, so that is what they say, direct flooding. Over drooping is the barrier may natural or human. So you might have put some barrier, and now this fellow will cross, the water will cross the barrier and come in. Okay, so that is called over drooping of a barrier. In first case where you call direct flooding, in direct flooding where sea height, when you say you are not putting any barrier in that case. Okay, so whereas in over drooping you have put some barrier, and that barrier has been crossed by the sea water. Okay, so over drooping can result in high velocity flow that can erode significant amount of land surface, which can undetermine defense structure. Then breaching, again it is a barrier, may be natural or human built. This breaching occur on open cast exposed large waves is where the barrier is broken down and destroyed. So in over drooping, it crosses over the barrier and it will try to flood, whereas in breaching it try to breaks the barrier itself and it try to enter. So somehow the coastal flooding is flood caused by the sea water. Okay, then storm surge, storm surge, storm flood, tidal surge or storm tide is a coastal flood or tsunami like phenomena of rising water commonly associated with low pressure weather system such as cyclone. So how the sea level or sea water is rising, that is because of this storm like tsunami or cyclones. It is measured as the rise in water level above the normal tide level and does not include waves. Most casualties during tropical cyclones occurs as a result of storm surges. Okay, so cyclones, when they are try to hit the surface, it try to disturb. So now we are going to take a case study. So we take case study with respect to India, so that we know something with respect to the data. So now we are going to take Tana Puyal as our case study, which has taken place around 25th December to 30th December 2011. Okay, so that was very severe, and that was occurred between the coastal between Pondicherry and Kadalur in early hours of 30 December with a wind speed of around 120 to 140 kilometers per hour. Okay, that is not a normal speed, it is a very high speed. See, around 140 kilometers is very huge. Okay, the offshore tide recorded relevant that the surge started to generate around 11 hours on 29th December with an height of 0.4 meters. So 0.4 meters was initially the height of the tide, which has raised to 0.68 meters at the time of landfall. Landfall is nothing but when it touches the land. Okay, that particular cyclone, it has generated and it is started move towards the land, and when it touches the land, it was measured as 0.68 meters. Okay, early hours on 30 December 2011. The field survey surge run up. Now we have to take next term, which is called run up. Run up is nothing but from the place where it touches the land and till what instant this enters into the land area, we call it as run up. Okay, run up of that particular cyclone, that is how we call. So when it touches the land surface, till sea it behaves differently. All cyclones will behave very differently when they are there in water. Okay, once they touches the land, some cyclones or most of the cyclones, we say it loses its speed, but in some case it reverse is also happening. Even for that also we have record. Okay, so a run up is till what distance it is able to proceed in land area. So that is what we call it as a run up. So you should know what is run up. And intuition distance at a 15 selected locations of cyclone affected. So in order to do our case study, what they have done is they have taken 15 selected locations affected area relevant to the variability level. So you have to take, see if that cyclone has crossed a particular area, we have to take above and below. Okay, so above and below with respect to variability level and along the coast. The condition that you should not change is our condition is only along the coast, because we are studying only with respect to coastal. Okay, so along the coast you have to take. Inundation distance is nothing but extended up to 30 to 230 meters landwards from the shoreline, and the run-up reached 1.6 to 3.2 meters above the chart. Okay, so run-up is around height of the tide which has passed the distance of 30 to 230 meters. In the area of places like 4 to 5 beaches we've taken, where it has level is from 2.5 to 3.2 meters of height of the tide. Think how much height it is, and the distance which it has travelled is around 230 meters. Okay, the inundation distance is mainly influenced by the slope of the beach. This is the thing which you have to highlight, and this is what we will even say in conclusion. What is our conclusion? We are going to say is the slope of the beach is only going to decide about the damage. When there is a huge slope, effect is more. When the slope is less, effect is less. Okay, in an area having a beach slope between 1 in 135, so for every 1 inch height in 135 and in 1 in 120, the distance travelled by the fellow or the below cyclone is 210 to 320. However, when your beach slope is 1:17 or 1:34, then the distance travelled is only 35 to 50 meters. So from the sea, the place where the intersect of water as well as your land area, from there we try to see our slope. If the gradient is very high, then the travel distance is also more, whereas if the slope is less, as you can see 1:17 or 1:35, where it is able to travel only 35 to 50. Okay, so this is the map which we are going to see. So we start, see here somewhere it has started here, depression has started somewhere here, and this depression starts moving. Okay, so when depression, it becomes a deep depression, then it becomes cyclone storm. It gains the required speed. Initially it will just build up at, we see this is India map. So somewhere here it is starting, that Tarna Poel was started at this place with the depression, then slightly it has moved where the depression has become deep depression, and this deep depression has converted into cyclone storm. See, once the cyclone storm has started moving, it is trying to move towards the shore, it gets even severe. So some storms will become severe and some will loses its power. Okay, whereas the Thane Puyal which hit Tamil Nadu was gaining when it traveled towards the shore. So started with the depression, deep depression, then cyclone storm, then it has moved to a severe cyclone storm and very severe cyclone, and it starts to hit. So once it hit, again it will ask to come down, so it becomes severe cyclone storm, then depression, and finally low pressure when it has touched the Kerala. Okay, this is why it has not moved, because you have Western Ghats here. Okay, so Western Ghats will try to stop it, and it has become low pressure area. So from high pressure area to low pressure area, the travel was there, and it was finally came to end. Now, so now we can see this is the place where it has hit the land surface first. So now this we are going to take into our consideration. So above this we will say a place with name as north, and below which we will take a place and name it as south. So where now when you see next upcoming slide where I say north, which means the place above the instant at which it has strike. See, even this area also had some effect. Okay, when you see this map, it is very clear Chennai is above. Okay, so that is what we are going to see. So data and method of case study. So you have to collect the data. So surge can be measured directly at coastal tidal station. So we have tidal stations and all, as the difference between the forecast tide and observed rise of water. There was another method also for measuring the surge, which was developed by pressure sensors based wave and tide recorders. Okay, above all this, in IIT Madras they have kept in so many places the measuring tide gauge. So that tide gauge was very helpful under this Tana Puyal. Okay, so that has helped them a lot in try to acquire the data. So first thing was getting the data. So these are the 15 location. In the 15 location we have tried to record it. Okay, so some place I told it is 196 north from the instant of that place where it has stuck, and from there with respect to angular degree we say it is 196 north. You can see here in this map with the north we are saying the distance. So from there we try to say it is north, and then this is and all is south, which means it is below. And in the landfall location, this is the place where it has hit the shore. Okay, so you can see the in terms of meter what is the height. So where it has hit is the maximum height, which is 3.2 meters height. That means tide height was 3.2 meters. You imagine how much high tide it is. Okay, and it was, see, you can see it from there to north as well as from there to south. You had around 2.85 and 3.1, and then it was gradually reducing on the north, similarly on the south, but it is not so as, because we have taken more places on north. Okay, so you can see here 1.62. okay, and the slope, beach slope, I told no, when the beach slope is in terms of 1 is to how much degree, then you can see the place where you have more slope, then the distance traveled by the cyclone is more. You can see here it is 1 is to 135, it is around 210. It is 1 is to 105, which is around 130. So 1 is to 120, you can see 230. So whereas when you see Chennai, our Marina Beach, you can see it is around 1 is to 190, so it is around 169. So when any cyclone try to hit, then just by seeing the beach slope itself you can say till what distance it will try to enter inside the place. So the conclusion is only with respect to beach slope, that is entering is more. Okay, but the place where it touches, you will have tide as more tide. Okay, now result, surge level along the coast. In general, surge height varied between 0.2 to 1.1 meters. It is observed that the time of occurrence of surge varied with the location, as the position of the cyclone changes with respect to time. So where the cyclone is moving, there you will have more. Okay, the tidal record of Chennai, Nagapattinam, and the location showed with the surge started occurs from 29 onwards, whereas Kadalur with the surge started occur one day earlier, that is on 28th December onwards, which is likely to because yeah, kindly wait for 5 minutes. Sorry for the inconvenience. So the tidal record of Chennai about 190 kilometers away from the north of landfall location. So the place where it has hit, from there we are around 190 kilometers away north. Similarly, Nagapattinam 120 kilometers away south of the landfall location. Okay, the location showed that the surge started to occur from 29th onwards, and for Kadalur it has started one day before. The surge started on 28th itself, because usually storm surge can begin to rise a day before the storm hits. So before its hitting, you will have a surge. Now we say the new term called surge. So what is surge? So surge is nothing but you have a cyclone, and that cyclone has not entered the land, but it has some adverse effect, which means it will have high shower of rain. So that high shower of rain we call it as surge. Okay, so in some places you will have more surge, and some places you will have less surge. Kadalur and Pondicherry are very close, so the place where it is going to touch, we have seen it is around Pondicherry, whereas Kadalur receives one day before itself it has started with surge. Okay, now this is the surge graph we say. For 3 locations we are showing here, and we can see there in terms of meter. So what is the surge level? This, the dotted line, we say it as surge. So this is before effect, before the storm has, or the cyclone has hit, it has having some disturbance like very heavy shower, so that we call it as surge. Then you have rise in tide, then observed sea level. So this is tide and this is observed sea level. So normal tide to the increase in tide. So normal tide is, when you say 1 meter, it is around 1.4 meters. Okay, this is for one place A, this is for another place B, and one more place we take into consider is C. So A is Chennai and B is Kadalur, where you can see the observed sea level is more only in place Kadalur. Okay, because Kadalur is close to the place where it is going to hit the land, whereas Chennai we have seen it is far away north, and the last fellow is Nagapattinam is far away south. So you can see the tide, whereas the tide and the observed sea level is very less in case of Nagapattinam, and even in Chennai you can say it is okay, but when you see with respect to Kadalur, it has around twice of Nagapattinam. And even surge, and during the cyclone also only you have getting the rain, so that is why everything gets merged in case of Nagapattinam. Whereas here, before cyclone hit itself, you will have a very huge volume of water, so that is why you can see a graph difference between Chennai, Kadalur and Nagapattinam. Okay, so discussion, The recorded sea level data at Chennai indicates that the surge started to occur around 11 hours on 29th December with an height of 0.2 meters and later gradually raised to maximum of 0.4 meters around midnight. Okay, in Kadalur, the surge started 11 o'clock at 28th December itself. Continuous rose with the time and reached a level of 1.1 meters at the time of 00 on 30th December. The sea level recorded at Nagapattinam shows a different trend in surge level. The highest surge was 0.3 was noted at the time of 19 hours 29. Okay, so you can see the difference. So here at 11 at 29th December it was 0.2, whereas at the time itself in Nagapattinam it was 0.31, and when it has got to 0.4 in Chennai it has become 0.1. So it is very clear that cyclone has moved from Kadalur to Chennai, not to Nagapattinam. So initially Nagapattinam was high, then it has moved towards Kadalur and Chennai. So that is why you can see initially we were 0.2 at the time itself. This fellow was 0.3 Nagapattinam. Then once it has moved in, it has 1.1 here. So when it has 1.1, Chennai was 0.4 and this has become 0.1. So it is, we can clearly see how the cyclone has moved. So this is because of the location, usually the south side of landfall location associated with the lowering of sea level. This is the structure of the earth itself, that is northern hemispheres. So south, when you have a cyclone, so south of the cyclone will receive less, okay, and the north of the cyclone alone usually gets more, and even in most of the time this is only will happen. Okay, then result, run up along the coast. The run up showed higher value near the cyclone, that we all know. Run up is nothing but what I have told, the distance that is going to travel in land. Okay, the maximum run up of 3.2 meters occurred at a distance of 5 kilometers northeastern side of landfall location. However, on south side the maximum run up was 2.8 and which reaches 5 kilometers distance. At the distance of 190 kilometers north of the landfall location, the run up was only 1.62 meters. Okay, so run up is not as when you say with respect to your meters. So here there is a slight change. South receives more than north, so run up will be more in case of south when compared to north. Okay, so this is the graph. You can see here, this is in terms of meters we have mentioned what is the height of the tide which has entered. Okay, so it is maximum at the place where it has touched. Okay, it is around 3 meters, remaining and all is 2 meters, and then it is here 1 meter. So here and all it is very away from the cyclone, so the rise in tide level is very less compared to this area. Okay, so that is what they show in this map. So what is the rise in the level of tide? Okay, so unlike run up, the inundation distance are highly variable along the coast depending upon the core shore geometry. So again we will conclude that only depends upon the angle, slope angle, the affection, the what you get disturbance is more. So if the slope is very gradual or gradient, then the effect is less. If the slope is more, you get more effect. Okay, so that is what the conclusion, what they mean to say. So wherever you can see the slope is more, then you are getting more. So this is Marina Beach. So you can see here, when you see the slope, you cannot see the slope in the graph, but it has been mentioned in terms of this 169 meters. We have seen already that slope is more in case of Marina Beach, so it has effect is more. Similarly here also slope is more. We can even slightly we can go back to that slide where I showed you what is the slope. So you can see here it is in Marina Beach, then in places in near Kanchipuram, that Periyambakkam, and in place where Silver Beach, we call it as Kadalur Beach. So all that three places you can see here, you will have more. This is 169, 210, okay, and around here 230. So this is Silver Beach. So you can see here at Silver Beach, okay. So then this is again with respect to slope. See, at least you can draw these graphs in your paper where you can claim that the surge will be more when the slope is more, okay. See, 1:55 and 1:90. You can see the surge. This is only gradually increasing, this is suddenly increasing, okay. Till this instant it was nothing, then suddenly there was heavy surge. So 1:40 you can see there is no much, gradually it is increasing, you don't have any sudden surge and all, okay. So even if you see there is very less, you don't have any surge at all, it is only more or less it is like a plain surface. So let us move on to the second case study. Fluvial, when you say flood, it is nothing but whenever river gets overflow, that's all. So first one what we have seen is coastal flood. Now it is for river flood. Sir, you can ask me, is there any such case here? Yeah. So our case study will be on Adayar River, okay. So climate change impact on Indian subbase. The case study we are taking is Adayar subbase. In order to visualize according to the climate projection flood map, we are going to take for 100 years return period. So for this they are using softwares. I will just say what is the software is. So they collect the previous year's data and they try to use this software called ARCGIS. So with this software they are able to predict for the next 100 years, and they predicted that it is going to have a climate scenario from 34 to 91 point compared with the present climate scenario, and they come to a conclusion that the flooded area ranging, now it is around 12% is your flooded affected region, which may increase to 26.4%. So there is chance for increase of flood affected area. So Adayar basin, when they have taken in that Adayar basin, climate change from 34.3% to 91.9% for the next upcoming years of till next 100 years, and the projection shows increase in flooded area from 12%, it will increase to 26.4%. So these data at least you can write it in exam point of view. You can say what is the software they are using, with that software what they were able to predict for how many years, and what they predict for the change in climate, and then you can write what is they can going to predict, that what will be the change in flooded area, okay. Then they may give some conclusions, you can try to follow and try to construct some type of barriers so that the affected areas can be reduced. The Adayar sub-basin located between 13.33 19 longitudinal to 79.51.12 east, and all the 4 direction they are saying is low lying area in the northeastern coast of Tamil Nadu, India. The Adayar river originates from a group of tank present in Kanjipuram district. Intermediately, some areas and all you have blocked and you have built buildings, but it starts from Kanjipuram. So when you take very old map, then you can identify. But what to do, since the city has grown, we have covered most of the places and we have tried to construct it, but it starts from a Kanjipuram from various tanks. Though it starts a group of tank, it appears as a river only after receiving surplus from Chembarambakam tank located with sub-basin. So we all know there is a big pond, the tank, we call it as Chembarambakam. So if it gets more water and if you try to open it, then only your Adayar river will get water. The length of Adayar river is around 42.5 kilometers. So think, it is not a very small, it is a very big river of 42.5 kilometers. From downstream of the river, 15 kilometers of this length comes under Sydney city limit. So that 15 kilometers of 42.5 comes under city limit itself. On the whole, the width of the Adayar river changes from 20 meters to 200 meters. The total catchment area is nothing but the place where you store water. So that is called catchment area of Adayar sub-basin is around 700 kilometers square, which means what we are saying is the total area which is there to store water, and 24% of this area is urbanized. So we have tried to use it. Okay. The Adayar sub-basin is considered as one of the rapidly urbanizing area since 2000. So we are trying to close it. So this is Adayar sub-basin, Chennai metropolitan. So this is the region which comes under Chennai metro. So that is what they say. Out of this total, around this region that comes under the Chennai metropolitan area. So in 1976 and 1985 and 1996, 205 and 208 and 215 are the years which they have taken consideration for the data. Okay, so in 76 the rainfall was around 346.6 mm. In 1985 it was 729, and then in 1996 surplus water from Chembarambakam tank mixed into Adayar river, which is around 282.2 mm per day rainfall was recorded. In 205 it was 361 mm, and 208 it was 322, and 215 in 2015 it was around 345. So initially it was very high, then this year when in 85 it was very high, but on general it is around 300 mm. Okay, and this is how they are going to do that simulation. So observed climate, future projection. So this they do. From this observed and future they try to draw IDF curve. Similarly, land use map and DEM data. DEM data is nothing but very old map, and this is land map. From there they get basin data. So basin data is the total land area of your Adayar river. So this base area plus your IDF graph they take and give it as an input to the simulating software. So here they use simulate software, again they use simulate software here. So with this first software they were able to find the drive storm runoff hydrograph. So they are able to obtain from this hydrograph, again by using some additional data they try to generate flood plan area. So this is what we need, flood plan areas and the flood depth map. So if the flood is coming, what will be the depth of flood in the region. Okay, so From there I have just giving an about what is that simulation. It is HEC-RAC is a one-dimensional hydraulic model which is used to simulate the surface water elevation along the rivers for a specified discharge of hydrograph. So HEC-RAC model requires geometric data, flow data for simulation. That is what they have taken. So you can see they have taken the data. Is one side of the data is climate and another side of the data is land usage. So that two they try to take and they try to simulate, and then they use a software called RECGIS, so which generate the geometric data consisting river. Then they finally get the profile. From that profile they try to give the flood. Okay, so this is how that is showing the map. The result is the observation clearly shows that the increase in the flood area will have some severe impact on people living near the banks of Adayar river. I think when you see Saidapet bridge, you can clearly see, okay, in near the Saidapet bridge, we don't know whether they are living inside the river itself or they are living on the side. When you see from far, it will be as if they are in the river itself. Okay, so that is what they say. When the flood, some severe impact will on the people living. Furthermore, these floods map help in identifying the flood zones in Adayar sub-basin, which can assist the government in decision making and policy framework. In addition, proper channelization. Channelization is you have to give the path for the water to flow. You are not supposed to close all the channel. If you try to close all the channel, then water will try to flow outside the river. So that is what they say. In addition, a proper channelization of Adayar river is required from the upstream end of the river. Similarly, the impact of flood can be decreased by providing adequate drains. So drain is nothing but channelization in the surrounding area. Finally, it is recommended to construct the flood walls along the river bank. In Saidapet, even same in Saidapet, they have constructed to some extent, but they have to do some more. The above suggestion can certainly help in ensuring the safety of the people living near the Adayar river. So I think with this we can stop today's class. So we have seen totally of 4 case studies, and with respect to syllabus there are 3 more case studies, so that we will try to see in the upcoming class.